Okay, my last example here is when you have a polynomial on top of a monomial. And again, it's about finding the GCF again, as usual. So, what's the greatest common factor of 14, 35, and 42? Well, it's harder to do it that way. So I think sometimes the easiest way is to do it like this. If I break the problem up and look at them as little pieces and work them out each separately, it might be a little bit easier. The GCF of 14 and 7 is 7, but the 14 has a factor of 2, and the 7 is times 1, of course. They both have x to the first power in them, but the top has 2 extra x's. That's my first part. Here, they again have a factor of 7 in common, times 5 and times 1. They both have x to the first power in common, with 1 extra x on there. And here they have a 7 in common. This is times 6 to give you 42, and that's times 1 down there. They both have x to the first power in common with nothing left over. So now when I reduce out commonality of pieces here, I have those pieces left. But we can't forget the signs. This 2 is positive, that 1 is positive. So 2 over 1 is 2. With an x squared. This 5 is going to be positive, because it was positive 35. 5 over 1 is positive 5 x. Last piece, 7 and the x canceled out. What's 6 divided by positive 6? Technically, 6 to the 0 over here. But when you have x 0 power, that should hold also. And you can see x to the 0 power crosses out and becomes where it comes where anyway. So just a constant of positive 6. Bottom has what value as a monomial. So you just take the monomial letter and set it equal to 0, and that's what x cannot be. Problem. The answer squared plus 5x plus 6 as long as x is 0. And the last example here, a little faster. 6 divided by 3 is